but I got a couple things to mention. So tomorrow, not that you guys have to worry about it, but for your freshman, sophomore, and junior colleagues here at Ponderosa, is registration day for next year. And so the schedule is just a little bit different tomorrow than it is most days. And obviously, like, our Wednesday schedule is usually different anyway because of the homeroom. And so they're dropping homeroom, so you won't have to worry about that tomorrow, which is nice. And they're but they're taking that homeroom time, that half hour or so that they dedicate to homeroom, and they're front loading it at the beginning of the day, so that anybody that has registration, so freshmen, sophomore, and juniors, there's a video that counseling put together that they're going to show about like how to deal with it remotely, because we don't want to have those pieces of paper that you walk around and get your teachers to fill out and sign, right? Everything's going to happen virtually this year. So your schedule is just a little bit different tomorrow than it normally would be, which is already different on a Wednesday. So just make sure you check out the timing on that for when your classes are going to be. For us, we're meeting at 10 o'clock instead of 9:20. So we get a little later start. So like first period and registration all happens at all through together. Like, so it's like school starts at 7:40. First and registration, video, like all that's going to happen all at once, which just kind of pushes everything back a little bit later in the day. So like second starts at 9:10, third's at 10 o'clock, fourth is at 10:50, and so on. Obviously, we don't have any registration stuff to worry about, so we'll just keep rolling on with what we've got going on. We're actually making our way towards the end of this first unit, which is a basic overview of the kind of things we're looking for once we actually get to some data. So intro to statistics is really just about kind of learning some stuff for the first time. It's brand new. Some of it's super easy, some of it maybe not so much. But the way that it looks as of right now is that we'll be back hybrid next week. That's kind of the way that the plan has gone. I still plan on live streaming classes because I do have some folks that are synchronous learners that are not necessarily taking stuff through Edgenuity because maybe this class doesn't really exist in an Edgenuity setting. So I'll still be live streaming every day, and we'll kind of figure out what that schedule looks like. But basically we're going back to that cohort A on Mondays and Wednesdays, cohort B on Tuesdays and Thursdays, and then everybody at home on Fridays, I think, from what I can tell. There's a board meeting tonight, so I think they're gonna kind of make some decisions after that from school to school, right? The district makes a decision on whether we're back full in person, hybrid, or if we're all remote, but each high school has the autonomy to kind of figure out what they want to do with that. So more on that coming later this week. But let's roll on. I want to get you guys out of here earlier than usual today. So I'm going to share my screen. Copies of what you need are at school. I made copies for the whole week. So you can pick those up if you haven't done that, or if you need or want to make your own copies, of course. I will always link those to our announcement for today. Okay, so we're into lesson 5, and we're going to do one today, and we'll do a practice one tomorrow. So that's why today's 5A, and tomorrow will be 5B. As always, submit your handwritten work for whatever you did, or however you're taking notes to Canvas, so I can give you some credit for that. And if you have some older stuff, make sure you get that in. I'm happy to take any old work and drop that missing and give you something for it, right? The closer, how should I say this? The shorter the time between when it was due and when it give it to me, that's how many points you're going to get, right? If it's super, super late, you're not going to get nearly as many points as if, oh man, I forgot to upload it, I'll get it to you the next day or whatever. So I'm happy to give you guys plenty of credit. Completion and effort for me is always the key to success in this class. That's what I care about, okay? So here we go. I'm going to share my screen. Let's do it. Let's get started with that. As always, give me a shout if you need anything. Stop me. I feel like I am talking to a web camera and not to people. So I'd love to hear from you guys if something comes up. Cool. Here we go. Lesson 5A. All right. We've talked a lot about important numbers like the middle and the beginning and the end, and You know, we did that 5-number summary last time. Now I want to talk about some outliers. And you can probably tell in the word, you might have even heard this before, as to what an outlier is going to be. Okay, and that's just part of a 4-limbed idea of how we describe data, which we call SOCs. It's an easy way to remember it. SOCs. Okay, shape, outliers, center, and spread. Okay, and so what we're trying to build, Sigmund and I are trying to give you with this whole intro to stats, right? Probability and statistics, really like this, the first half of the semester's intro to stats, is to try to give you that background as to what you could do with this moving forward. Because the world does not necessarily need people that know calculus, right? That's a lot of people, a lot of math people kind of head in a calculus direction. 100% of the world should understand statistics and what it tells us, because I mean, you are bombarded by numbers every single day. And if you understand that SOCs is a great way to understand a collection of data, that's really the complete description that we're looking for, right? You know, give me a whole big, huge set of data. God, I don't want to look at all the numbers. Okay, what I want to know is what shape does it look like when we graph it? Okay, are there any outliers? Are there like super, super small numbers or super, super big ones, right? Where's the center? Like, where's the average? Where's the middle, median, right? And then how spread out is it, right? Do I have a super wide spread of data, or is it all kind of jammed around one small space? And if I know all 4 of those things, and write down as much of that as you need to, really shape, you know, what does it look like? Visually, right? So shape is a visual kind of thing. And we'll get to that. And we've actually done that a little bit, right? We've looked at stem and leaf, which kind of gives us a little bit of shape. It was more of a vertical one. Histograms are great for shape, box plot, stuff like that, because I can see, you know, I kind of think of histograms as being like the outline of a city. You know, for me, it's like a city skyline, and it gives me sense of where the center is, right? Where's downtown, really, the tallest buildings. Center, of course, like I said, you know, where's the middle? There's 2 kind of middles, right? Where the average is and where the median is. And those sometimes are the same and sometimes they're different. But that gives us a sense of what's going on. And then spread, how spread out is it? Okay. Now, the things that are in parentheses there for spread and for shape, we haven't really talked about yet. We don't know what skewness is, right? We'll talk about that for sure. And we certainly haven't talked about standard deviation, what IQR is, whatever that is, and then what range is, right? We haven't really talked about most of those. And today I really want to just focus on outliers, and we're actually going to use the idea of spread to help figure that out, okay? Cool. And so today is only about dealing with outliers. And so stop me or tell me to go back if you need me to, but I'm going to move forward. I'm happy to share this presentation with you guys after too, because I don't think I put it on Canvas yet. Okay, what's an outlier? That's all I really care about. Okay, fill in the blanks here on your notes so that you can get a sense for what we're talking about. Okay, outliers are just stragglers. Okay, they're the numbers that really don't fit with the rest of the data because they're so big or they're so small. They are extremes. Okay, and remember, extremes can be on either side, right? Super, super far this direction or super, super far that direction. And we'll talk about what super far really means, like how do we actually find an outlier for sure. But you can probably look at a set of data and be pretty close in picking what the outliers are going to be. And the problem with these is they throw off our stats big time. It's going to throw off my average. Like I had a couple kids in one of my classes not show up for my final for a semester. What'd they get? They got zeros. And if you're getting a 0, if I'm averaging zeros in and I look at a class average, huge, huge difference when I drop that down. They dropped them down like 5 or 10 points. It was huge. So when I think about how did my class actually do, I drop those outliers when I think about finding averages or finding middles, right? Because they're so far off. They are an abnormal distance away from all the other values. And we're talking about just random samples, right? Just, you know, I take an average of you know, every single kid that I gave a test to, right? I don't pick the best ones or the worst ones or the middle ones. I just look at everybody kind of randomly, right? And if you got an outlier, that's probably a problem, right? There's something wrong with the data that we've got. For me, the problem is that kids didn't show up to the final. right? And sometimes we call that bias, right? Now, they chose to not participate, and that's actually bias, right? It's not my bias, right? It's their own choice that some people might not choose to participate in whatever your study is. For me, my study was how did my kids do for a semester in Algebra 2, right? So that kind of bias, that selective choice bias, people don't fill out the survey, right? You send out a survey to 100 people. If you only get 50 of them back, it's not quite the data you're looking for, right? So all the data lies outside the other values in the set, okay? And we should be able, in general, to kind of see it, all right? But I want you to look at this example first, okay? Last semester, so Miss Sigmund is not just the data and decisions prop stat person, but she also teaches AP statistics, right? So all of these same ideas, but at an advanced placement level. Okay, and so dealing with AP math classes in this virtual setting is definitely a new challenge, as it is for basically every class, but check this out, okay? So early last semester, they gave an AP stats test, completely on campus, okay? All remote, okay? They said, okay, here's when you can start. Starts at 10 o'clock, okay? You can start taking it at 10 o'clock. And they just kind of left it open to see what would happen. Okay, so think about this. It was a 12-question test, okay? AP questions. Now, but these are old AP questions from like 2015, 2016, 2017, 2018 that have been released, that are out in the world, right? So think about this. What they did, what Sigmund and Lynch did, is they looked at and so this is a selection of times that it took for students to complete that test. Okay, 12 questions at an AP test, like May AP exam level. Okay, and so these are numbers right here that are how long it took them to complete that test in minutes. Okay, round to the nearest half minute. Now, if you're just looking at the numbers, it's really hard to get a sense for what's going on. Like, okay, I'm just looking at it. Like, they're not in order, right? So that makes it a little bit harder. I don't even know how many there are. I don't know how they're grouped together. I have no idea. And so obviously looking at the graphs are going to be a whole lot easier. So take a look at the graph instead. And there's the 5-number summary that goes with it. Okay. AP stats. 12 tests. Okay. Look at where the kind of the grouping of data is. Okay. But look at some of the numbers. One person took 2.5 minutes to answer 12 AP questions, okay? One person took 72 minutes, okay, over an hour. One person took 120 minutes. Now, on this list is actually one person that they didn't include. One person had the test open for 4 days. Now, okay, think about this. The person that took 180 seconds, so 3 minutes, so let's just round it up to 3 minutes, 60 seconds in a minute, so 180 seconds. That's 15 seconds per question. These questions, look at me for a second if you can see my screen. Like, they're this long to write out. Do you think someone could realistically answer 12 questions in 180 seconds? What do you think is happening there? What do you think is happening down here for a person to fill out a 12-question AP test in 3 minutes?
Cheating.
Yeah. Now, what about these two up the top here? What about the people that took a lot longer to finish the test? What do you think they might have been doing?
Not studying, sleeping.
Maybe. Like, for me, the people down here, I don't know. I mean, they might have already known these questions. How are you going to answer 12 questions in 3 minutes if you don't already know these questions? These are like, you should see these kind of questions, right? But the people that took a lot longer, what do you think they might have been doing to try to, like, here I am taking a test online, What do you think they might have been doing?
Playing games or being off the test.
Either like not doing what they were supposed to be doing. Like for the person that left it open for 4 days, obviously was not sitting there for 4 days taking this test. But remember, these questions are released questions that are already online. And if the questions are online, you can be damn sure the answers are too. And so I have a feeling that these people that were here, certainly this person, was probably like typing into Google 4 paragraphs at a time and pressing enter and seeing what comes up. Right. And so you can see that with these outliers, we've got an easy way to get a sense for what's happening with the people that are probably not with everybody else. Like you had 6 people here that finished it in, 20 minutes, or 4 people in 25 minutes, and 3 people in 30 minutes, and 5 people in 35 minutes. Remember, it's a histogram, right? So we've got the gaps between the bars. It's data here and then frequency, right? How many you had. So you had 2 people here that took 3 minutes, right? Because where is it? We got, let's see if you can look at the data. It's hard to see when you look at it this way. There it is, 2.5, right? And 3, right? There's no way. You just can't do it. And so we can easily look at outliers. There's the center, right? The center is kind of right around there, right? But also the spread, right? You can kind of visually see how the data is going to screw stuff up, right? So those people that took an overly long amount of time probably looking up these answers one at a time, right? So, all right, take a look at your next graph. Do you think you could probably circle the outliers? Go ahead and do it. Do you think you can pick the points on this graph? And so this is called a dot plot, where we just go to a certain spot and we put a dot for however many people. So one person had 5, one person had 7, one person had 10, one person had 15, one person had 19. 2 people had 21, 2 at 22, 5 at 23, 4 at 24, and then 1 at 25. Where do you think those outliers might be? Circle them. Now there's a form, we'll actually like make it official. How do we really know it's an outlier? How are we sure for sure that it falls outside the data? We've got a little formula that we'll use to be sure. So I'll show you what that looks like. But a lot of times you can probably be pretty on point. What do you think? Give me one. So remember 5, 7, 10, 15, 19, 21, 23. Give me a shout. Which ones do you think might be outliers? Or are you feeling pretty confident?
The 5 and 7 week outliers.
Definitely 5 and 7, right? Look how far away they are from the data. Like maybe the 10, right? Maybe the 15, probably not so much the 15, but it could be the 10 as well, right? Absolutely. Why? Because they're far away, right? They are way lower, or in the next case, I mean, look at the next graph, right? Could be just way higher, right, than the graph. Okay, so probably this 75 over here, this 85 over here at that next graph. Go ahead and circle those. I think those are pretty good, right? But the 35, yeah, I know it's just one of them, but it's pretty close to all the other numbers, okay? It's really just an outlier if it's far away. And especially if there's just like one of them, or maybe 2 of them. I didn't have, like if there were 8 dots here at 75, well, those probably aren't outliers if we've got so many data points at that spot, right? So single points, maybe 2 of them, maybe 3 of them, that are pretty far away, okay? And we can tell the same thing with histograms too, right? So there it is, right? Percentiles and frequency. I know it's kind of blurry, but, right? Maybe these over here, right? Even maybe this one down here at the bottom. Go ahead and circle those, right? It could be, right? I like these kind of being pretty far away. You got this big gap here, where nothing's going on. Even though there's only, maybe one thing right here, it looks like, because it's pretty close to everything else, it's probably still part of the center of the data. Yeah, obviously this is where it's all happening. That's the big one right there. But this one is between some bigger bars. So I wouldn't call that an outlier. We're just looking for really small values or really big ones. So maybe circle these 2. And I don't know, maybe this one could be. Maybe these 2, probably not though. And it's that whole probably, or I don't know, or how am I sure? Like that's what I want to get rid of, okay? When you look at these graphs, go ahead and circle any of the ones that you think might be outliers. Even if we're wrong, that's okay for now. And that's why I'm not circling them, because when we guess, we could be wrong. And I don't want to guess. I want to be right. Statistics is about trying to find the best way to represent data that is not misleading, that doesn't follow any agenda. I want the numbers to speak as much truth as I possibly can. So we've got a nice little formula for outliers, okay? And so this is what it looks like, okay? If we want to really be sure that we've got a kind of a guaranteed way to get this right, what we need to kind of figure out is, okay, like where do my outliers start at the bottom? Like where's kind of like my cutoff for the bottom, where everything to the left of that is definitely an outlier, everything to the right is more towards the middle, and the top half, right? So there's kind of like this lower boundary for an outlier, and there's this upper boundary for an outlier. Okay, and so you've got two kind of little formulas in here, and I know that IQR, like what the heck is that? There's a little box in your notes right below that. We'll talk about what that looks like. But have this formula, these two formulas written down, because we're going to find the lower boundary for outliers and kind of like box it off and say, okay, here's where that starts and ends. And then same thing at the top. All right, we'll have an upper boundary for that. Remember, Q1, that's your first quartile, right? When we did our 5-number summary, right, we found the minimum, the maximum, and the median. And then we had kind of like the middle of the first half. We called that the first quartile. And then we had the middle of the back half. And we called that the third quartile, right? So 25% and the 75%. And so what you're seeing is that anybody below, right, those are our possibilities. But we go even further than that. And we take this value in here, and we'll talk about what that looks like here in a second, right? We're going to take Q1, we're going to subtract something, right? And that kind of be where our boundary is. And we're going to take Q3 and we're going to add something to it, okay? And what we do is we take this IQR, which if you look at your notes right below that box, we're going to write this in. It says finding the interquartile range. I'll give you a formula for that in a second. Okay, that's what the IQR is. Okay, so we're going to take 1.5 and we're going to multiply. I know I'm using the X for multiplication. You can use a dot. You can call it whatever you want. But we're going to take the interquartile range. I'll give you a super easy formula for that. Okay, we're going to multiply by 1.5. Okay. We're going to take Q1 and subtract whatever that number is. We're going to take Q3 and add whatever that number is. Because like Q1 and Q3 kind of give us like that middle 50%, right, between 25 and 75. I want to kind of extend that boundary just a little bit further. So that's why we're going to multiply by 1.5. Okay. And when we look at that IQR, I just want to see how far away those quartiles are from each other. So we're going to take Q3 and subtract Q1. So there's kind of like a couple steps here. Luckily for us right now, day one, I just want to work on this right here, finding the interquartile range. Tomorrow, we'll actually find the outliers, okay? We'll figure out where all that is. So what I want to focus on today, but I still want you to have both formulas down there, right? So the first one, all right, the lower boundary, Q1 minus 1.5 times the IQR. Upper boundary, Q3 plus, kind of extending our boundaries out a little bit to figure out where those outliers are going to be, okay? But what's the IQR? Well, it's just the distance between Q3 and Q1. Like, hey, if I'm walking from 2 on the number line to 7 on the number line, from 2 to 7, how far did I go? Well, from 2 to 7 is 5, right? That's because 7 minus 2 is 5. That's all we're doing. We're counting that distance, okay? And that's what I want to do, okay? There's just 3 practice ones just on finding the interquartile range, okay? You guys good with that so far? You guys have everything written down that you need to write down? Because then we'll just use it, right? And again, today we're just going to do IQR, okay? So here we go. Practice number 1, okay? If we want to find the IQR, all I really care about are these numbers, Q1, okay, and this number right here, Q3, okay? And what I want you guys to do is find that interquartile range, Q3 minus Q1. That's it. That's all we have to do. Because if we can do that, if we can take, okay, 10.5 and subtract 3.5. Now, why am I taking the bigger one and subtracting the smaller one from it? Because I just want my number to be positive. I don't want to go the other way because then we've got some negative number, right? I want things to be nice and positive. So I take the big one, subtract the smaller one. And that's really the best use of these quartiles. Yeah, it's nice to know where kind of like the 25th person is in a, a line from 1 to 100, and the 75th, kind of nice to know that. But knowing that distance between them, super helpful. And that's all we're finding. It's how far away they are. So the IQR for practice A is 7. Pretty simple. Okay. Now, knowing how far it is from the lowest one to the highest one, that'll be really helpful for us too. That'll be spread though when we get to there. Here, we're just trying to figure out where these outliers are. But before we can do that, we just need to figure out what the interquartile range is, or you can just call it IQR. That's cool. All right. And then you can do B and C. Super easy, right? All you have to do is subtract. Calculators for sure, but nice to write it down. Okay, I definitely want to see at least these last 2 lines down here. You don't have to write down the formula every single time. You can if you want. Super helpful so that you don't mess things up. You don't pick the wrong numbers. Or if you did pick the wrong numbers, but then you did the number, you did your calculations correct, I can give you some points for that. When it comes to actually testing on this stuff, I'm a big fan of partial credit when you write stuff down. That's what allows me to give you some points. That's what I want to do. Give you any chance to be successful, okay? And they're already doing all the work for us here by finding the min, the quartiles, the median, the max. So nice, right? And of course, Google Sheets can do all that work for us. Now, I'm going to go back through. I don't know that I've graded everything, but I want to make sure that if you are using Google Sheets to do all this work, that you're doing it with the formulas and that you're not just getting the answers from somebody and writing the numbers in. Right, I want to just see that the formulas are in there because that's the key to this. And they're super easy formulas if you know them, because then it does all the work, okay? But there you go, Q3 minus Q1, okay, 88 minus 71, so the interquartile range is 17. And that's a number we're going to use to help us find outliers. Like for this set of data, is 48 an outlier or is it cool? Is 111, is that an outlier or is it close enough to the rest of the data? We're going to use that Q3 plus 1.5 times the IQR, and we'll do it tomorrow, no worries. And then same thing for the outlier at the bottom, Q1 minus. So kind of like taking this line right here and stretching it out a little bit. Like imagine that you have these boxes here. Same thing at the top, kind of stretching out our spread a little bit and kind of marking off some outliers. And there's C. Super easy. Take 89 minus 73, see what you get. All right, 16. And hey, if the median's 81 and the max is 100, those are pretty close together, right? But if the median's 81 and the minimum is 10, yikes, that's really far away from a center. Remember, we're using kind of an idea of center to help us figure out where we're at. Voila. Welcome back after a long weekend. Done. Submit that work to Canvas, and I will see you tomorrow, 10 o'clock. 10 o'clock.
Rosie, can you share the Google Slides?
Yes. Ooh, let me do that. Yeah, I'll do that right now. I'll do it on the screen over here. Yeah, this way you guys can go back, look at formulas again. Let me go to announcements. So I'll update the announcement with that. To do that, though, I need to do this. I got to go to my drive. Okay, when you guys have it uploaded, you guys are good to go. I will see you tomorrow at 10 o'clock.
Peace out, Rosie.
Peace out. Have a good one.
Thank you, Rosengren.
Thanks, guys. Later.
Rosie,
Rosie,
real quick, and then grab the paper, the packet.
Say that again.
Could I come to your room and then grab like the packet?
They're actually right outside the security desk. So if you walk into the school, security's on the left. There's a big table on the right.
Okay.
Like one of the first stacks of paper, and there's a folder there that has it like a label that says like prop stat. Like right above that folder, you've got last week's papers if you needed that, and then this week's it'll say right at the top. It'll say lesson 5A, and you'll see the graphs that we just did. So stop right in school. You don't even have to come up. You can come up if you want, but yeah, they're just sitting right there. Help yourself.
Okay. Yeah, thank you. Have a good day, Rosie.
Yep. You too. See ya.
See ya.
Okay, so if I was being distracting Rosie, my dog, like halfway through class, she came down here and she was trying to eat my hand.
That's all good. No worries.
Sorry about that, dude.
That's all good. No problem.
Also, I don't have printer ink, so I can just write this down, right?
Oh, absolutely. Yeah.
Okay, great. Thank you. Because I have pen ink. That's about it, really.
That's fine. Yeah, whatever works for you. I'm flexible.
Thanks, man. See ya.
Yep. See ya.